Hi there, we're going to look at some equations involving absolute values. Absolute values can be a little tricky because we have two answers. Let's look at this first one here. We have the absolute value of x equals 4. Well, by definition, the absolute value is that distance between 0 and that number. Well, if that number is 4, that's good. That distance is 4. And also, the distance here is also 4. So there are two answers for x. X can either be a 4 or x can be equal to a negative 4. And if you can check that by placing it back in there. If I say the absolute value of 4, that equals 4. Also, if I said the absolute value of negative 4, that would also equal 4. So that means with absolute value problems, we're going to have two possible solutions. Now, sometimes you might only have one solution, and sometimes you might not have any solutions, but you do need to look for two. So I could break this apart because what is inside of here can either be equal to 9, which is the easy one to solve for, because that just looks like normal, or what's inside of there could be equal to a negative 9, because this stuff inside of here could either be a 9 or a negative 9, following from that other problem. And then we would just solve it as normal. Add 1 to both sides. 2x equals 10. Divide both sides by 2, and x would equal to a 5. Likewise, I come over here. I'll add 1 to both sides and solve this one as well. 2x equals negative 8. Divide both sides by 2. And in this case, x would be equal to a negative 4. So you could substitute a negative 4 in there for x. And if you did, you would get 2 times negative 4 is negative 8, minus 1 is a negative 9. You would take that absolute value, and that guy checks out and works. You can plug a 5 in there, and 2 times 5 is 10. Subtract 1, that's 9. Take that absolute value, and that's 9. So this one also works. We're going to look at a few more that are a little more complicated. All right, here's another couple of problems to get us going. When you have something like this, the best thing to do is get that absolute value symbol all by himself. So let's move this 6 over to the other side so that we have the absolute value symbol all by himself, so that I can then say, I can look at the positive in the negative case, but don't try to do it until you move all other junkola to the other side. So now I can look at this as 3/5 x minus 9 equals 6, or 3/5 x minus 9 equals negative 6, because what's inside of here can either be a positive 6 or a negative 6. First thing I'll do is slide that 9 on over, so let's add 9, add 9. I'll have 3/5 x equals 15. Getting rid of this fraction, I'm going to multiply both sides by 5 over 3 times 5 over 3. X equals, let's see, these are fractions, so I'll look at 3 goes into 15 5 times. 25 is a possible solution. I'll want to check that, but it's going to work. And then I'm going to add 9, add 9. 3/5 x equals, that's a 3. Multiply both sides by 5/3 times 5 over 3. Well, this one is really pretty, isn't it? 3 goes into 3 one time. X equals 5. And there's my other possible solution. Now this next one looks somewhat like this. The absolute value symbol is all by himself. I'm cool with that. But let's really look at this before we go and solve. This says the absolute value of this deal equals negative 4. Now, tell me, when is the absolute value of something equal to a negative number? It's not. No solution. You could go through and look at a positive and a negative case, try them both, and you would find that neither one of them worked. Or you can just look at it the front end and go, hey, absolute value can't equal a negative something. and then move on. On our last couple of problems, we'll look at some really tricky ones. On these problems, you will need to check these. When you have absolute values on both sides, it's not like we can isolate it. So what you're going to do is you're going to look at x minus 2 equals the positive one of this, which is 2 minus x, or you're going to look at x minus 2 equals the negative of that whole thing, which is what we've been taught to do for our absolute values. Now, these are tricky, and just because you solve it, you get something, doesn't mean that it works. You will need to check it. So let's add x here, add x. You're gone, and I've got 2x minus 2 equals 2. Add 2, add 2, 2x equals 4. So I have x equals 2. I'm going to check this before I'll say that it works. 2 minus 2. All right, that's 0. 2 minus, oh, that thing works. Cool. So this one checks out. Let's try this dude. X minus 2 equals negative 2 plus x. And then I'm going to subtract x from both sides. Oh, watch this. Negative 2 equals negative 2. The x's drop out. Oh, there's not another solution here because this thing always works. So let's see what that means. Because that could mean, well, since the x's dropped out and this thing is true, that might mean that it's always true. This one here is tricky. So let's investigate this a little further because I see something very unusual going on. I know that this guy works. Let's try and see if, say, 1 works. 1 minus 2. If x is 1, we'll write like this. Let x equal 1. If x is 1, I'll have absolute value of 1 minus 2 equals absolute value of 2 minus 1. This would give me absolute value of negative 1. This would give me 1. Ah, that one checks out. So x can be 1. Let's try another one. Let x equal 7. That would be 7 minus 2 equals 2 minus 7. That'd be the absolute value of 5. Does that equal the absolute value of negative? Well, it sure does. This checks out. Oh my goodness. It doesn't matter what I put in here. This is always going to work. Not only is there this solution, but everything works. So I'm going to say for this one that x can be anything from negative infinity to positive infinity. All solutions work. Oh my goodness. This one really was tricky, wasn't it? So sometimes you'll get 1 solution, no solutions, 2 solutions. In this particular case, all those solutions work. But when I look at it, I see that it really does look like the same thing twice, and it really doesn't matter what you put in there for x. After I kind of study it a little bit, I kind of go, oh, I see why that works the way it does. So we're going to take that little technique and we're going to work this next one. So I've got negative 1/4 x plus 1 equals, I'm looking at the positive case. And then I'm also going to look at the negative case. Now I doubt something really tricky like that will happen on this one because it's not really the same thing twice, you know. But we'll just have to see. So I'm going to say negative 1/2 x minus 1/3. I don't know why I always squish it in there. Okay, so the way I'm going to solve this one is I'm going to multiply everything through by a 12 because I sure don't like fractions. So everybody's getting a 12. Put it back on blue. When I distribute this 12 to everybody, chunk, 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 I'll get a 4th times 12. That's negative 3x plus 12. Oh, that's so much better. 6x minus 4. That just makes me so much happier. I'll add 3x, add 3x. and then I'll have 9x equals, I'm going to add 4, I'll get 16 here, divide both sides by 9, and I will get that x equals 16 over 9. I want to check that, make sure it works, but I do believe that it will. So you can just plug it into your calculator, make sure it equals the same thing on either side, or you can number crunch it by hand. So here, I'm going to do this again. I'm going to multiply by 12. So let's take my red pen, because it makes things so much easier. I've already done it, but just have a couple of signs to change. So I'm going to get negative 3x plus 12 minus, equals minus 6x, and the signs change here, so that's plus 4. Don't forget that I changed signs with this right here. So let's add 6x to both sides, and then I'll get 3x plus 12 equals 4. Subtract 12, 3x equals, let's see, 12 minus 4, I think that's a negative 8. And then x is negative 8 over 3. And I believe you'll find that that one works as well. All right, now some of these get tricky, and if you have any trouble with them all, be sure and send me an email, and I'll be glad to help you out with these. Send you a solution to a similar problem or something of that sort. All right, y'all have a wonderful day. Bye now.